In a world that is perpetually captivated by the allure of diamonds, the recent unveiling of Shipra, a 50-carat lab-grown diamond, serves not only as a testament to human ingenuity, but also raises critical questions about the very fabric of value, luxury, and ethical consumption. The making of Shipra is not merely a technical milestone. It is a narrative woven with the threads of environmental ethics, economic shifts, and a futuristic vision of sustainability. This colossal, lab-made marvel prompts us to revisit our definitions of authenticity and to reconsider what we hold as treasures in our material world. Heralded as a breakthrough in gemstone engineering, Shipra emerged from the laboratories of Gemesis Tech, a frontrunner in the burgeoning industry of synthetic gemstone production. This 50-carat diamond is not just large by any measure, it's a giant leap for the lab-grown diamond industry, which had previously seen a ceiling of around 20 carats for such high-quality specimens. The process of creating Shipra involved a complex orchestration of high-pressure, high-temperature HPHT systems, combined with advanced chemical vapor deposition (CVD) techniques, refined over years of research and development. Researchers at Gemesis Tech had to overcome tremendous technical challenges. The larger a synthetic diamond, the more difficult it is to maintain the necessary conditions uniformly throughout the crystal growth process. Achieving this feat required not only technological innovation, but also a deep understanding of the crystalline structure of natural diamonds.
Creating a large diamond in the lab has always been possible in theory, she notes, but making it economically viable at this scale, that's where Gemesis has really changed the game.
Lab-grown diamonds, identical to their mined counterparts in every physical, chemical, and optical characteristic, are created through remarkable technological processes. At the heart of this science is the ability to replicate the natural conditions under which diamonds form. There are primarily two methods employed today: high-pressure, high-temperature (HPHT) and chemical vapor deposition (CVD). The HPHT method mimics the natural conditions found deep within the Earth, where carbon atoms are exposed to high pressure and temperature, eventually crystallizing into the diamond structure. Conversely, CVD involves breaking down molecules of a carbon-rich gas, such as methane, in a vacuum environment to allow carbon atoms to slowly accumulate on a substrate, layer by layer, forming a diamond.
Each method has its strengths and complexities. HPHT is akin to creating diamonds in a cauldron under the earth, while CVD is more about painting with atoms. The choice of method can influence not just the quality, but also the characteristics of the diamond created.
The introduction of high-caliber lab-grown diamonds like Shipra is not just a technical achievement, it is reshaping the very landscape of the jewelry market. For centuries, diamonds have been a symbol of wealth and exclusivity, primarily due to their rarity and the challenges involved in their extraction. However, lab-grown diamonds, being more accessible and affordable, are democratizing this symbol of luxury. This shift is causing ripples across the global market. Traditional mining giants are now competing with tech-savvy startups that offer not only a more ethical alternative, but also a product indistinguishable from mined diamonds. This evolving scenario is pushing the industry towards transparency, innovation, and sustainability. Industry analyst Maria Lopez comments, "The trajectory is clear. As consumers become more conscious and regulations more stringent, the appeal of lab-grown diamonds will only grow. This is an exciting time for the industry, which is being compelled to adapt quickly." The rise of lab-grown diamonds like Shipra heralds a new era in gemstone fabrication, one where ethical production and environmental considerations are at the forefront. The reduced ecological footprint of lab-grown diamonds, compared to the often destructive mining practices, is a substantial advantage. Furthermore, the ethical assurance that these diamonds are not blood diamonds, those mined in war zones and sold to finance conflicts, adds a profound layer of value. Looking forward, the technology that brought Shipra into existence is not static. Innovations in energy efficiency, production scalability, and even the potential for new kinds of gemstones are on the horizon. As Dr. Sharp optimistically points out, what we're seeing is just the beginning. The possibilities for what can be created in a lab are nearly limitless. As the curtain pulls back further, revealing more of what's possible in the realm of synthetic diamonds, a more sustainable and ethical future seems not just probable, but imminent. In this light, Shipra is not just a marvel of modern science, but a beacon for future innovations in luxury, ethics, and environmental consciousness. The story of this 50-carat lab-grown diamond is, at its core, a story about redefining value for a better world.